Hello everyone. So in today's lecture we are going to see about the regression analysis, and let's see what is regression. So technique, it is a technique which is concerned with preceding some variables by knowing others. So while knowing one variable, we have to determine or we have to detect the what will be the upcoming variables, and the process of predicting a variable y using x. So let's see how to find regression. So uses of variable x to predict some outcome variables y. So it is just like the things which we do in the case of coordinate in mathematics, that by substituting the value of x we have to find some values of y. So it tells you how values in y changes as a function of change in values of x. So correlation describes the strength of a linear relationship between two variables. So we have seen about the correlation in the previous lectures, and here linear means straight line, and we have also seen that there were three types of correlation: the positive, negative, and no correlation, and all are being depicted in the graph with a straight line. But in regression, it tells us how to draw the straight line described by the correlation. So the first one is there was a straight line, and in the second one, that is in the regression, we have to learn that how to plot that or how to draw that straight line. So this is regression, and we have to calculate. It calculates the best fit line for a certain set of data, and the regression line makes the sum of the square of the residual smaller than or any other line. So the points which are smaller than the perfect line is the sum of the squares has been calculated of those lines, and they are made with the graph. So regression minimizes residual. So here the points which are not on the line is very less. So by using the least square method, a procedure that minimizes the vertical deviations of plotted points surrounding a straight line, so we are able to construct a best fitting straight line to the scatter diagram points, and then formulate a regression equation in the form. So what we have to do, we have to calculate the y bar, or we can say that the value of y with the help of the straight line equation, that is a plus bx, and y bar is equal to y bar plus bx minus x mean. So we have to calculate these all things for calculating y and y bar, and after calculating the y and y bar, we have to find the value of b using the values found in the above equations. So this is the formula of calculating the b, and let's see an equation. So regression equation describes the regression line mathematically. So how mathematically it is defined? It is defined by the help of slope intercept formula, which we have already studied in our previous classes. So y equal to a plus bx, or we can say mx plus c. This is the same equation, the same line. So here b equal to slope, and the change in y is depicted by this red line, and this change in x is also depicted by this x line. And what are the intercept? The intercept is the point from the origin to the first point that is on the y-axis. So this is the intercept. So we can see this example, the same example which we have taken in the correlation, that is number of hours spent in studying, which is directly proportional to the final grade in course. And this is the line, the predicted final grade in class equal to 59.95 plus 3.17. So what is this 3.17? This is the number of hours you study per week. Okay. So we have got this the value of r as 0.88, the square r of 0.88. So predicted final grade in class equal to 59.95 plus 3.17, that is the hour of study. And predict the final grade of someone who studies for 12 hours, and final grade equal to, so we have to multiply it with 12. So final grade equal to 59.95 plus 3.17 into 12. So multiplied by the number of hours we will get the value of 97. So someone who studies for 1 hour will get the final grade as 63.17. So it is very much easy now to calculate the grade. So here is an exercise. So sample of 6 persons was selected, and the value of their age, that is the x variable, and the weight is demonstrated in the following table. The weight is y, So we have to find the regression equation and what is the predicted weight when age is 8.5 years. So here we have to multiply with 8.5. So let's see the serial number, age that is x and weight that is y. So we have to calculate the table that is age, weight xy and x square y square. So here after calculating this x, xy, x square, y square, we have to sum all this all in the total one, that is the sigma x, sigma y, sigma xy, sigma x square, sigma y square. After that we will substitute it with the help of the above equations of regression, that is x bar equal to 41 by 6, y bar equal to 66 by 6, and the total after calculating all these we have to calculate the value of b, that is equal to 0.92, and after this the regression equation is y bar x equal to 11 plus 0.9 x minus 6.83. So this is the equation and we will get the value of y equal to 4.675 plus 0.92 into x. The x is the value which has been asked in the question. So in question we are given to find about the 8.5. So the value is 12.50 kg. And similarly for 7.5 we are getting the value of 11.58 kg. So here we create a regression line by plotting two estimated values of y against their x component, the 7.5 and x. So here we can see that the line is being drawn with the help of relation. So similarly we are having the second exercise. This is the same one of age and blood pressure. So we have to find this correlation of 25 years. So we have to do the same things, the x, y, xy, and after that we will find the total one, that is sigma. Substitute the value into the formula and we will get the age like this: y bar equal to 112.13 plus 0.4547 into x. That is the x is the value which is given in the question. So for 25 the BP is 112.13 plus 0.47 into 25, that is 123.5. So what is multiple regression? We have let's study about the multiple regression. So multiple regression analysis is a straightforward extension of simple regression analysis which allows more than one independent variable. So in this multiple regression we are having more than one independent variables. So that's all for this lecture. We will see more in the next one. Till then, stay tuned. Thank you.